For this example, we are going to look at negative and positive outputs as well as zero outputs, increasing, decreasing, domain, range, and specific x and y values. So reading a bunch of information from one graph. The first piece of information that we're asked for is to find the interval when f of x is less than 0. So f of x is less than 0 means we want negative outputs. Remember, this is our x-axis. Anything above it is a positive output. Anything below it is a negative output. So negative outputs, we are looking below the x-axis. So we have negative outputs here as well as over here. And we want to write that in interval notation. It's always x intervals unless you're asked for range. So looking here, this first piece is somewhere between -1 and -2. So maybe -1.5. And since it's a 0 on the graph, we're not going to include that. All the way up to here looks like it's between 0 and 1, maybe not even halfway. I'm going to call that a 0.3. And we're not going to include it because it has a 0 output. It's where we stop being negative. So we counted for that whole interval. And now we just have the other piece to look at. So we're going to union that with this piece here. And it looks like it's halfway between 2 and 3. So I would say 2.5, where we see our 0 output. After 2.5, like 2.6, it's already negative. And then going off to the right indefinitely. So we have an we have an arrow going down. So we're going to have an open parentheses. This is going to go all the way to x's infinity. It's going to keep going down as we go further out to the right. So lots of negative outputs following that arrow down. If we compare that to positive outputs, we're looking above that x-axis. So this piece here is above, as well as this piece. And we want to write that in interval notation, always using x values unless you're asked for range. So looking to the left here, this is going up and over. So to the left, as x is negative infinity, the y values are going up. They're staying way above the x-axis. So you have positive outputs above there. Until you get to this point here, which we said was about -1.5, you have a 0 y value, so we're not going to include that. It doesn't have positive y values anymore. If you plug in -2, you get a positive y value. If you were to be able to plug in -3, -5, you would see as you go further into the x values toward negative infinity, you have positive y values until you get over to -1.5, where you get a 0 y value. So we're done with that interval. Union, we have this other interval here. We said the 0 is about at like 0.3, comma, over to 2.5. We're going to do round parentheses because that's where the y value is 0. It's no longer positive or negative. And then we're going to estimate where the y value is 0. Where is the output 0, or the y value 0? We had 3 spots. And I just estimated these. You could estimate them, and I would say that it is correct. There's no perfect answer for these when it's not labeled. I would say -1.5 when x is 0.3, and when you plug in x is 2.5. Looks like a 0 output. Now we're going to switch gears. We're not splitting up the x-axis anymore. Those are for outputs. The next part asks, where is it increasing? So for increasing and decreasing, you're tracing the graph left to right. So first part, when I trace this graph, I want to figure out, am I rising or am I falling? So read it just like English, left to right. As I trace this graph, I'm going down. So I'm going to label this with a negative. That stands for decreasing. Any soft peak here actually has a slope of 0. So that's not decreasing anymore, but it's not increasing yet either. But this piece, as we follow it left to right, starts rising. So we have a positive slope. We are increasing. Then we have this soft peak. We would say the slope is 0 there, not increasing or decreasing. But this piece, we are falling left to right, so I'm going to put a negative. We are decreasing. So writing this in interval notation, first interval I'm asked about is increasing. So increasing from here all the way over to here. If you trace the graph, you're rising left to right. So in terms of x values for these intervals, we could say somewhere between 0 and -1. So maybe I'll call that negative 0.7 in that x value there, to somewhere between 1 and 2, maybe 1.5. Always going to have round parentheses on there because it's technically not increasing at that last number. It has a 0 slope. And actually it maybe looks like it's beyond halfway between 1 and 2. So you call it 1.5 or maybe 1.6. I'd be fine with either answer. Just looks like it's maybe a tiny bit past halfway. Could go either way though. And then the next part says, where is the graph decreasing? So it's decreasing on this interval. So all the way from -infinity, since we have that arrow, all the way to 0.7 is what we called that x value here, this piece. And then our other piece where we were decreasing was over here. So we're going to union that with, we called it about 1.5 or 1.6, all the way over to infinity. We have an arrow at the end, so it indicates it keeps going. Next part says, what is the domain? So domain is left to right. So from the left, well, we have an arrow, which means it's going to keep going more and more left to -infinity, to the right, which has an arrow, which means we're going to keep going out to x is +infinity. And now we're looking at the range. This is the first time we look at y values when we write an interval notation. Everything else is x values. So we're going to read this down to up. Well, if we look down, the graph ends with a down arrow, which means it's going to keep going down to -infinity. And then if we look up, the graph ends with an up arrow, which means it's going to keep going up to +infinity. Infinities always have round parentheses. We don't include them. Next piece says, what is f of 1? So plugging in the x value 1, this is saying what is y? So if we plug in the x value 1, we want to read what y is. Get rid of some of this so it's easier to read. So the x value 1 has a y value of 2. So f of 1 is 2. I'm going to skip the next one and go down to this one here. It says, what is f of 0? Finding another y value, f of 0 is -1. And then this asks it the opposite way. We're given y, we want to figure out what x is. So for which x is y equal to 2? So I want to look along the line y equals 2 and see if there are any x's that cross it. So there are a few. We have y equals 2 is crossed 1, 2, 3 times. So we want to figure out those x values that correspond to it. So the first x value I would say is x equals somewhere between -1 and 2. So maybe x is -1.7. I'm writing in the wrong spot. Move it up. X equals -1.7 or maybe -1.8 for that first y value. Our next y value, -1.8. Our next y value is of 2 comes from x equals 1. And then our last y value of 2 comes from x equals maybe like 2.1. So we have 3 x values that correspond to f of x equals 2, or y equals 2.